Hello, 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 everybody, and welcome back to more of the 2008 Grade 7 Math Contest, Grade 7 Gauss Math Contest, put on by the fine folks at the University of Waterloo, and we're up to question number 22 in this video. In the diagram, PQRS is a trapezoid with an area of 12. RS is twice the length of PQ. So I might do something like call PQX and RS2x, just to represent that relationship. The area of PQS is, so this area right here. What is there to do? What is there to do here? Well, the only thing I really know is the total area is 12, and I know these two lengths. Okay. So, what can we do? I take it from the picture that, so trapezoid means that we got the two parallel sides. I take it from the picture that these are meant to be the parallel sides. They don't actually say that explicitly, but just trying to think for a second. I'm trying to wonder if that actually impacts the problem. Because if they are parallel, I know how to do the question, but, yeah. Well, I'll worry about that later on after the video. But, so we got PQ. I kind of wish they'd explicitly said that these guys were the parallel sides, even if they're not. Or, sorry, even if they think that should be obvious. But, what can we do? Well, what I'm going to do is I'm going to drop a height here. Okay. And this height is a height for it's the same as the height for QRS, and it's the same height for PQS. So we might call this H. Doesn't really matter what he is. But as I've already said, PQ is X and QR is 2X. We understand that relationship. So PQS has a base of X. Let's draw the picture a little better. Base of X and a height of H. So PQS is 1/2 X times H. No idea what exactly that is, but PQ is 1/2 X times H. Alright, but then QRS has a height of H and a base of 2X. So QRS has an area of 1/2 base times height. Well, the 1/2 and the 2 cancel out. We're left with XH. But in total, we know that 12 is the area of PQRS. But that's just going to be PQS plus QRS. It's the sum of these two triangles that we've broken this down into. But that's 1/2 XH plus XH, and that's going to be 3/2 XH. Okay? But that is 3 times 1/2 XH, and that's 3 times PQRS, or PQS. Okie dokie. And then, well, then I know 12 is 3 times the area of PQS, so 4, divide both sides by 3, is the area of PQS. So my final answer is going to be 4, and that's B right there. Okay. Now, I did sort of rely on PQ being parallel to RS. I would say that's apparent from the picture. Could I draw a trapezoid? So trapezoids have to have one parallel side from another. Can I draw a trapezoid that has X and 2X? Yeah, I certainly think I could. And I feel like that might mess the question up, and it might make the question possible to have multiple answers. But we've got our answer here, 4. With this assumption, we get an answer of 4. And so these questions are not poorly made. I mean, I would argue this question should probably mention that PQ is parallel to RS. But in general, these things aren't poorly made. So there shouldn't be one way to do this, assuming they're parallel and get a 4, and then another way to do this, assuming that these aren't the parallel sides and get an answer of 6 or something like that. There should only be one correct answer. So if I can find a way to make a trapezoid with one length twice as long as the other, have an area of 4 in this case, then that's my answer. So I go with that. Bit of annoying that they didn't mention that. I really wish they had drawn the parallel lines there. But, wasn't that hard. I'm probably overthinking the question. There we go. So, B4, that's going to be our answer. And we'll move on to question number 23. Feel free to leave a comment if you had a way that did this that didn't require you to assume that these sides are parallel to each other. Because I can't currently think of a general proof or anything like that. But, so move on to question number 23. I will see you guys for that in the next video.